Hey, geometry. So we're in 7.6. This is the last part of chapter 7. So the plan for this week is notes on 7.6 today. On Wednesday, we will do a review on all of chapter 7. And then on Friday, we're going to take the chapter 7 test. All right. Once you finish the 7.6 notes that you're listening to me give right now, you can work on 7.6 homework for the rest of class, or you can work on the test and quiz corrections from the chapter 6 test and the 7.1 through 7.4 quiz. If you haven't gotten them back yet, they're in a pile on my desk. You can maybe ask the sub if they'd be able to pass them back to you with your name on it. All right. The corrections are going to be due this Friday as well. So in 7.6, there's not a whole lot to talk about. We've got these three relationships, and these three relationships here should remind you of what we talked about in chapter 5 with the orthocenter, the incenter, and the centroid. Okay, so it kind of reminds us of those a little bit. So in 7.8, what this says, this is if two triangles are similar, the lengths of the corresponding altitudes. So if I look here, I've got altitude AD, there's AD. If I compare that to altitude FJ, there's FJ, that ratio is going to be the same as if I were to compare any of the two sides. So for example, if I took AB and compared that to its corresponding side FG, that would be proportional. All right. Now it doesn't have to be AB and FG. I could compare, AC to FH, or I could compare CB to HG. But once you pick that direction, you got to kind of stick with it. All right. And this is the same thing for the 7.9 and the 7.10. All right. What we can say is that if I look at LP, notice there's LP, and I compare LP to RT, that ratio is going to be the same as if I were to compare LM, there's LM, to RS. All right. So it's just making those proportions. All right. And then you can probably guess in the last one, if two triangles are similar, we know that the lengths of the corresponding medians, so CD divided by YZ, that's going to have to equal AB divided by WX. All right. And it doesn't have to be AB over WX. It could be AC over WY, or it could be CB over YX. All right. So you got lots of options, but the important thing is that whether you draw an altitude or an angle bisector or a median, that ratio is going to be the same as the ratio of the sides. All right, it's all proportional. So here in the example, we're trying to find x. A few ways we could set this up. If I look at the altitudes, right, so 16 and x are the altitudes here. So I'm going to compare the altitudes, so 16 over x, and that's going to have to equal the comparison of the sides, so 20 over 15 equals 20 over 15. All right, now when I look at this, I see this and I kind of want to simplify this first. So I'm going to say 16 over x equals, if I divide these by 5, that's 4/3. So now I can cross multiply. We get 4x equals 48. And then we can go ahead and divide by 4. And we should see that x is 12. All right, so there we go. There's x. On the next page, we've got the triangle angle bisector. So this says an angle bisector in a triangle. So let's first draw a triangle. You can draw this triangle be, whatever you want. Doesn't exactly matter. I think mine kind of looks like a right triangle. It doesn't have to be a right triangle. But we're going to draw an angle bisector. So from the angle, now I'm not trying to go to the midpoint. Okay, I'm trying to cut that angle in half. So in other words, I want this angle right there to be bisected. All right, so those are equal. But again, this segment here is not equal to that segment there. This is not the midpoint, just an angle bisector. So if I have an angle bisector in a triangle, it's going to separate the opposite side into two segments that are proportional to the lengths of the other two sides. So let's go ahead and put some letters on this. All right, so we got some 4 letters there. And then I'm going to go ahead and I'm going to say that IZ compared to IL So again, the sides I'm comparing, there's my IZ right there. And here's my IL, all right? That ratio is going to have to equal AZ, there's my AZ, over AL. Oops. Trying to figure out my colors here. There you go, AL. Okay, so IZ over IL is going to equal AZ over AL. Now that's one way you could write this proportion. We know that there's a lot of different ways to write the proportion. So another way to think about this is if I compare IZ to AZ, so if I compare the green and the red, then I could also set that equal to IL over AL. I could compare the purple to the orange. And you can kind of see that when I cross multiply, right? Up here, IL times AZ, well, there's IL times AZ. And IZ times AL, well, there's IZ times AL. So it's not going to make a difference how you set this up. Again, as always, the most important thing is that whatever you compare it in the same order, all right? Next up, we're going to just kind of do this application problem here. We're trying to find the value of x. Now, a few ways we could set this up, all right? I'm going to write down a bunch of ways, and you try to think about if I set this up correctly. So one way would be this. Another way would be this. And another way would be this. Okay, so think for a second about which of those would make sense, which of those would work. You can go ahead, pause the video, think for a second. All right, you can resume the video. And let's see, so the ones that work, well, if I compare x to 4, that means I would have to compare 6 to 13. X over 4 in this direction would mean 13 over 6 in that direction, so this first one would work. And then if I look at the second one, we've got 6 over 4, so 6 compared to 4 would have to equal 13 compared to x. Well, I'm comparing the same thing in the same order, so that would also work out for us. And then the last one, let's see, so we've got 6 over x. We're kind of cutting across the shape almost, equals 4 over 13. We're going in opposite directions. We're not comparing, like the 6 and the x don't have anything to do with each other, so we cannot make this statement. So this would not work out for us. All right, so that would be a bad way to write this. All right, now using one of the good ways, which we can use this first one here, if I cross multiply, we get 6x equals 4 times 13, which is 52. So that means that x equals 52 over 6. And this reduces to be 26 over 3, right? That's a good answer. You can leave it as 26 over 3. If you want to write it as a mixed number or a decimal, you can as well. This would be the same as 8 2/3. Or you could say 8.6 repeating. Don't round it unless you're asked to, so don't put 8.67 or don't round that unless you're asked to. But any of those answers would work. Last one here, find the value of x. I would say just go ahead and pause the problem right here, see if you can try it on your own before I give away the answer. All right, and you may have set it up differently than me, but the way that I chose to set it up was I compared the x to the 14, so I said x over 14, which means that I have to compare this side to the 11. Now the question is, what is this side? Well, if the entire distance is 20, I can subtract the x to find that missing side there. So I know that this missing distance has to be 20 minus x. So 20 minus x. All right, that's one of a few different ways to set this up, but you definitely need to use the 20 minus x regardless of how you set it up. So when I cross multiply, we've got 11 times x is 11x. And then I cross multiply with the 14. So when I distribute that, we get 280 minus 14x. We can go ahead and add 14x on both sides. And so we end up with 25x equals 280. I know that 25 goes into 275, 11 times. And I've got a remainder of 5. So that means that x is 11 1/5. Or you could write that as 11.2, or you could leave that as a mixed number if you want. Mixed number would be 56 over 5. All right, so any of those answers are great. I kind of like the 11.2 the best, but any of those answers will be just fine.